So I said in the last lesson we were going to put ActionScript coding to one side and focus instead on drawing tools and Flash animation. So this is an example of a Flash animation that I've set up, and in later lessons I want to show you how to put this together. But I'll cross that one off for the moment, because in today's lesson we're going to be focusing on drawing tools. And I'm not going to be able to have enough time to talk about every aspect of every drawing tool, so you're going to have to, if you want the details, to experiment with these tools yourself. And you can see that as I'm hovering over the tools, a tooltip appears to tell you what it is. Also some properties will appear for you to experiment with. And in addition, if you come across the if you look at the drawing tools with the icon in the bottom right hand corner and you hold your left mouse button down, you'll see additional drawing tools to have a look at. But in this lesson I'm going to be restricted just to talking about creating a trapezium. And creating a trapezium is a good exercise because there isn't a default tool to create a trapezium in Flash. So you have to use one of several methods to create one. And I'm going to be showing you 3 different methods to create a trapezium in this lesson. So I've created a new project, a new ActionScript project called Project 5, and I've just saved that in the usual way. And to start with, I want to show you how to make a trapezium using the pen tool. So the pen tool is already selected there. To make it more accurate, I want to switch on a grid, so I'm going to go into the View menu. I'm going to go down to Grid, and then Show Grid, and then a grid appears. I'm going to make it snap to the grid as well. View, Snapping, Snap to Grid. All that means is that when I click on the stage, it will default to the grid points where they cross. Okay, so it won't go into the spaces between. It will always go to where the grid lines cross, and that means that it's more accurate when you're creating a shape like a trapezium. So it might be nice if I could set up the fill color. At the moment I want a red to a black linear gradient. So it would be nice if I could go into the pen tool fill, but I can't. The reason for that is that I create an open shape like that one, which you can't apply a fill to. So it just doesn't let you set a fill initially. It will only let you set a fill afterwards if you create a closed shape, which is what I'm going to do now. So I've got the pen tool selected, and I'm just going to click on the stage to create a trapezium. You can do it more accurately than me. I'm just going to show you the general principle of creating a trapezium, and you can see there that there's a little O showing, and that means I'm going to close the shape, which will allow me to fill it. To come out of the pen tool, just click on the selection tool, and then to fill my shape, remember it's a gradient from red to black. So I've got my shape selected, go into the fill, and then go into the bottom left hand corner where there's a linear gradient tool, and then click. I'm also going to remove the outline, the stroke colour, by clicking on the black and then using the white with a red line through it, just to remove that black outline. And to get back to my fill colour, I just have to click on the fill button, and I have options here to change how the fill looks, and I want to change that white colour to a red colour, so I double click on it. Unfortunately my screen isn't large enough to show the colour palette, so I'm just going to press escape and move my colour menu downwards and then do the same again and click on red. So I've now got a red to a black gradient, and I'm just going to put that colour menu back, and you can see that my trapezium now looks quite similar to the one I created earlier. So I'm now going to show you a different way to create a trapezium. So I'm going to delete that trapezium and remove the grid, view grid, show grid, and the snapping view, snapping, snap to grid. And this time I'm going to create a trapezium from a square. And to create a square, I'm going to need to use the rectangle tool, which is that one. And the fill is already set up from a red to a black, so I just need to draw myself a square. And it's quite difficult to draw an accurate square unless you press the shift key at the same time, and then you get a perfect square. So to turn this into a trapezium, I'll just move it into the middle first of all. To turn this into a trapezium, use the sub-selection tool, the white cursor, then click on the edge of the shape, and you'll see little white vertices appearing, and what you need to do is to click on one of these bottom ones, and it will turn into a filled blue vertex, and then you can either click and drag the vertex, but I'm just going to undo that, or you can use your keyboard, your left arrow key, which will make sure it stays in a straight line at the bottom there, which is what we need for our trapezium. So I'm just doing the same thing on the other side with the right arrow key, and I have there now a trapezium created from a square using the sub-selection tool. So that's maybe a bit less accurate than using the grid and the pen tool, so I'm going to delete that, and I'm going to show you now a new and very accurate way to create a trapezium. And to start off with, I'm going to select the rectangle tool again, and I'm going to use a solid colour this time rather than a gradient to start off with. I'll change the fill colour later on. And I need a square. So that's holding the shift key down again to create a perfect square. And the next thing I need to use is the free transform tool. But before I do, I just want to show you what the free transform tool does. So if you're also looking at the transform menu, you'll see these numbers change as I use the free transform tool. So you can see there that's changed from 100%, and that's changed from 100%. So you could either use the free transform tool or the transform menu to achieve the same effects. So the rotate has changed. I put the rotate back again. I can also skew it if I put my cursor in the right place, and that's changed that. So it's a general deformation tool, and it's quite useful for several things. I'll just show you another form of deformation using the selection tool. Make sure your shape is not selected. Click on the stage, have your selection tool selected, and then put your mouse cursor next to the edge so that you can see a curvy line. Then click and drag, and you can create some interesting deformations that way. However, I'm going to delete that because that's not what I want to do. What I want to do is to get my square back, hold shift down again, use my free transform tool, and all I need to do, or all I want to do, is to use the slant function of that free transform tool to create one edge of the trapezium. And to create the other edge of the trapezium, I'm going to copy and paste that first shape, and then flip it horizontally to turn it into a trapezium by putting one shape on top of the other. Now these are two separate shapes, and I want to make a linear gradient fill. So in order to be able to do that, I need to turn it into one merged shape, and I use modify break apart to achieve this. So I'm going to use modify break apart and then modify break apart again. And because they were both the same colour and because it was a solid colour, it wouldn't have worked if it was a linear gradient. At that stage, I've now got a merged shape which I can now apply a linear gradient to. And the same as before, I'm just going to drag that down, change that white to red. So I now have a trapezium made out of two slanted squares, one of which was flipped horizontally. So I'll just remind you of the three methods I used there. The first one was the pen tool with the grid showing, view grid, and then view snapping, snap to grid. The second method was using the rectangle tool, and then I used the subselection tool to access the vertices, and then I used the arrow keys to move those around. And then the third method I've just shown you, I used the rectangle tool and then the free transform tool to make it slanty. Then I copied and pasted that slanty square, rhombus I suppose, and then I used in the transform menu the flip selection horizontally, which created a mirror image of that rhombus, and I put one rhombus over the other rhombus, and I used modify break apart to break both of those shapes into a single merged shape, which I could then apply the linear gradient to. So as I said at the start of the lesson, I can't possibly go through each function of all of these drawing tools. And remember, there's some underneath these menus if you click and hold. I just don't have enough time to do that, so you're going to have to experiment. I suggest you experiment with shapes that are also that have this selected and have this not selected. This merged shape that I've created is very similar to creating a shape with this deselected, and it has slightly different properties to when it is selected, and I will just show you an example of the type of experiment you can carry out. What is the difference? How is it different? Well, there's one difference straight away. You can't do that with a shape that is an object. So I recommend that you have a look at all these different drawing tools, see how they work, play with their properties, and just generally find out how to make good pictures using Flash. And in the next lesson we'll be looking at stop motion animations. So if you followed the advice in the previous lesson, you will have had a look at some of these drawing tools in more detail. For example, you might have had a look at the Polystar tool and tested out the options and changed the number of sides, and then tested it and found you can make all kinds of different shapes with that tool. I just deleted that. You may also have looked at submenus, for example this oval primitive tool, which you can test out some options here to see what they do. Make some interesting effects with it. Again, I'll just delete that. So if you haven't done that already, I suggest you have a look at these tools in more detail to make sure you're familiar with them. Because when you are, you can make quite sophisticated drawings, such as this wheel. And in this lesson I want to show you how to animate this wheel using stop motion animation. And this form of animation is similar to something we've seen before, which is animating a button. If you recall, an animated button has 4 frames across the top, an up state, an over state, a down state, and a hit state. And the hit state, as you recall, was where you defined an area for the cursor to activate the button to change it from the up state to the over state. And when you clicked on it, it would go to the down state. stop motion animation uses the same principle. It uses several different frames, each time with a gradual change in that frame to create the illusion of movement as the frames are played one after the other at a fast speed. So as you recall, to create a new frame, you right mouse click on the next frame and click on Insert Keyframe to copy the contents of the previous frame into the next frame. And then you can modify the appearance of the next frame so that you create this gradual change to create this illusion of movement. So I'm going to adjust the rotation of that wheel, and I'm going to use the transform menu rather than the free transform tool which I showed you in the last lesson. And the reason for that is that you can make more precise changes. So I'm going to make a 5-degree change in each of these frames, and in doing so I'll get a gradual kind of rotating wheel effect. So if I go back to frame 1 and press enter, you can see the beginnings of an animation there. But of course a wheel doesn't usually rotate around a fixed point, it usually moves forwards as it rotates. And you can either guess the amount it moves forwards, and then you would change the X position at each frame by your guessed amount, and you could try different values until it looks like it's the correct amount. Or you can use a mathematical formula to link the angle of rotation to the amount the wheel moves. And if you use maths, then you will get a more precise looking animation, a more realistic animation. So I'll show you an example of how you would go about calculating this particular relationship. So here's the wheel, and you may remember from your maths lessons from school days that the circumference, which is the whole length of this circle, is the same as 2 pi times the radius of that circle, which is the distance between the edge and the centre. And we want to find out how far the wheel moves forwards, and that distance is the same as the distance of the arc that the wheel moves through when it moves through the angle. In our case it's 5 degrees. So it turns out that this is a simple proportionality relationship. If you can find the proportion of this angle relative to the whole angle of a circle, which is 360 degrees, then you can also find the proportion of this this arc relative to the whole circumference. So if we divide A by 360 degrees and then multiply that by the circumference, we get the arc. And the arc is the same as the distance that we want to move the wheel forwards. So that's how we calculate. That's how we find this mathematical relationship. So if we put the numbers in, our wheel has a radius of 115 pixels, and I'll show you how to use Flash to find that in a minute. So we're rotating it by 5 degrees each time, so the numbers we want to use is 5 divided by 360 times 2 times pi, which is 3.14, times the radius, which is 115, and that turns out to be 10 pixels that we need to move our wheel through in each frame. So I'll show you now how to find the wheel radius. So our width of the wheel, we can see here, is 230, although it's quite deceptive because this wheel is a symbol and it's a rotating symbol, and the width is the width of the binding box along the horizontal plane. So if you looked at frame 4, the width of this symbol is the distance between this corner of the binding box and this other corner of the binding box along that horizontal line. which is 281, rather than in the first frame 230. So if you're looking at the width of a rotating symbol, you should actually go inside the symbol to look at the graphic itself. You can either double click on the symbol on the stage or double click on the symbol in the library, and you'll see that the symbol name comes up next to scene 1. And now if you click on the graphic, you'll see that the width is 230, which is the diameter of the circle. The radius of the circle is half that, which is where I got my 115 pixels from. So that's the first pitfall, finding out the radius of your rotating circle. There's another pitfall, because we now want to move this wheel 10 pixels in each frame. So let's have a look at our X position. This is the value we want to change. So in the next frame you think, I want to make it 160, the frame after 170. So let's have a look at frame 2. In frame 1 it was 150. In frame 2 it's already over 160. And in frame 3 it's over 170. So it looks like the X position of this wheel is moving, even though the wheel is actually staying in the same position as we've seen before. If I press enter, it's just rotating around that static position. So what's going on here? What's happening is the position that's being registered is the place where you can see this cross here. That's the registration point of that symbol, and that position is rotating about the rotation point, which is in the middle of the wheel. And you can see as the wheel rotates, the registration point is moving, and that's why you get this changing X position even though the wheel is actually staying in the same place. So how are we going to fix that problem? What we really need is for the registration point to be at the same place as the rotation point. So I'm going to delete the animation I've made so far by going right mouse click and remove frames, because it will get awkward otherwise. I'm now going to go inside the symbol, and I'm going to move this wheel so that the centre of the wheel is over the registration point. So as it rotates, it should rotate around the 0, 0 point of the symbol, which is how the Flash knows where it is on the stage. So inside the symbol it's 0, 0, but outside the symbol, that 0, 0 point of that symbol is actually not 0, 0, it's 150 by 85. So each symbol has its own kind of X and Y axis. So if I'm clicking on this wheel, you'll see it's 0, 0. So how do I get that centre point of that wheel over the 0, 0 point of this symbol? Well, the easiest way is to go to the Align menu and to use Align Horizontal Centre and Align Vertical Centre. So that wheel graphic is now over the 0, 0 point, the registration point of that symbol. I'll go back to scene 1 now. You can see it's actually moved on the stage as well. So let's move this back. So I've moved the wheel now, so the registration point is at the middle of the wheel. But if I try to rotate this, well, I'll use the free transform tool to show you. If I now rotate it, it's now rotating around that corner, which is not what we want. I'll just undo that so it goes back. So it's rotating around the where that O is, and if you use the free transform tool, you can move the position where it rotates around. So it will now rotate around the middle of that wheel because I've just dragged that over. So let's have a look at that in action. Let's have a look at that in action with the rotate tool first. If I rotate the wheel now, you can see it's rotating as you would expect it to. So that's the other pitfall to fall into with when you're animating with rotations. You've got to be very careful about where the registration point of your symbol is and where your rotation point is as well. And generally you want your registration point and your rotation point to be in the same place, although not always. It's entirely dependent on how you want a particular symbol to rotate. So let's put in our frames again and add our rotation back in. So I'm going to put 5 in again, then right mouse click, insert keyframe, and then put 10 in, and then right mouse click, insert keyframe, and then 15 in. If I go back to frame 1, it looks just exactly the same as what it did when I started. But now if you look at the X position, it should be the same each time. It's 266.1 in every frame. So it's no longer changing with the rotation, it's always in the middle, which means I can now go and increase my X position by 10 each time, which is what I calculated I needed. So 10 pixels, because it's rotating by 5 degrees. This one needs to be 280, and this one needs to be 290. So let's go back to our first frame, and it's looking like it might work. So here's one I made earlier, and we'll be able to see that it does in fact look realistic. So in the next lesson I'll be showing you an alternative type of animation to achieve the same effect but with less work, which is called tweening. So in the last lesson I discussed stop motion animation, and I showed how animations are illusions of movement created by images that change slightly between frames when they're played quickly. And in this lesson I want to talk about tweening, which is a way of automating the process of creating frames. And in fact something called in-betweening predates computers, because this was used in the film industry when they were creating animated movies by hand using paint and drawing tools like pencils, coloured pencils, that kind of thing, not when it wasn't on computers. In-betweening was a popular skill, and senior artists would create keyframes for the animations, and the keyframes were the frames of the movie where an important graphical change had taken place. And these wouldn't necessarily be frames that were directly after each other. They would leave the frames in between for junior artists to use those keyframes that the senior artists had created as guides, and then the junior artist would create additional frames in between them, and that was known as in-betweening. So Flash still uses the term keyframe, and almost in-betweening it's using the word tweening instead, which is an automated process. So let's have a look at this tweening. I've got here a dark circle which I'm going to say is a keyframe, and a light circle, which I'm going to say is another keyframe. If you were in the movie industry several years ago, you would have senior artists that create these keyframes, and the junior artists would fill in drawings based on the two keyframes, using those as guides. What Flash allows you to do is to automate the process, so you can create two keyframes and then tell Adobe Flash to create a tween, and then it will create the in-between frames automatically, saving a lot of time drawing. And in fact, there are two main types of tweening in Flash. One is called shape tweening and one is called motion tweening. And shape tweening is mostly used for colour and shape changes, whereas motion tweening is used for movement changes like rotations and translations. And there's a difference between how the two are set up. In motion tweening, the tween is added first, and in shape tweening, the keyframes are added first, and I'll show you that in a few minutes. I also want to give you a project at the end of this lesson, but I'll discuss that later on. So let's have a look at shape tweening first of all. So I'll set up a shape tween in the same way as you've seen on that slide. A dark circle. Dark blue is already selected, so I'm just going to, I'll just make the stroke colour invisible, holding down Shift to create a perfect circle. So I've created a dark blue there. Remember, I just said that we need to put in keyframes first for a shape tween, which is what I'm making here. So I'm going to insert my keyframe at frame 40 in this case. So I right mouse click and insert keyframe, which has copied the contents of frame 1 into frame 40. So I'm going to change the colour of that to a lighter blue, and I'll just show you what it looks like at the moment. All of those frames are with a dark blue, and then it's just frame 40 with a light blue. But if you right mouse click anywhere between frame 1 and frame 40, and then say create a shape tween, then that will put in all the intermediate frames in between those two colours. So if I click on frame 1 and press enter, now what happens is there's a colour change. If I go Control Test to do a test compile, you can see the same thing on that test Flash movie. Now I said that shape tweens can be used for colour and shape changes, so I'm just going to apply a deformity using the selection tool. I'm just wanting to get the cursor looking like a curve on this. There we go. So I just want to make it a different shape. And now if I do a control test, it's changing the shape and the colour at the same time. And you sometimes find that the shape tween might not go as you planned. Adobe Flash might fill in frames in a way that you don't want it to. And in that case you might have to put additional keyframes in to make sure it works properly. Or you could use something called a shape hint, which is under modify, shape, and then you can go add shape hint. And what that does is it adds, usually it adds only just one at a time, but in this case it's added 3, which is fine. I'm just going to put 1 on each edge like a triangle. A, B and C, you can add more using modify, shape, add shape hint. I'm going to go to frame 40 and I'm going to align those to where I want the points to correspond on that shape tween. So if I go control test, let's see how that's worked out. It looks pretty much the same, which is fine because there wasn't really a problem with that particular shape tween. One more thing I want to show you. At the moment, frame 1 to frame 2 runs at the same speed as frame 39 to frame 40. So it's a kind of smooth animation that goes all at the same speed. If I now change the ease, if I go into the click anywhere between frame 1 and frame 40, put ease at 100%, or at 100 anyway, then go control test. You can see it's going fast at the start and slow at the end. And I can do the opposite by clicking there and putting an ease in instead. Slow at the start and then fast at the end. Right, so I think I've shown you enough on shape tweening. So let's talk a bit about motion tweening. And I'm going to motion tween this dot at the top. Although first I'm going to make sure my background will show during the whole tween. Because if I make a tween at the moment, if I go to frame 40 for example, and insert a frame, you'll see that my background is restricted to frame 1. So I'm just going to press Ctrl Z, and I want to see more frames here, so I could use the frame zoom if I want to, or let's put that back roughly, or I can click and drag further along to see some more frames, and I'm going to go to frame 120, right mouse click and insert a frame, and that will just make sure my background remains displayed throughout the animation. So I'm also going to lock that there. That means I can't do anything to the background while I'm adjusting this animation. So I just want to show you first of all how a motion tween works, and as I said, there's a difference in how you set this up. Instead of inserting a keyframe to start with, you insert frames instead. So don't insert a keyframe with a motion tween, insert frames, and then then go right mouse click anywhere on that area and choose create motion tween. At the moment there's no motion tween, no motion anyway, there's a tween there, but to add the motion, go to the last frame. If you want, you could use a different frame, but I'm going to go to the last frame, and that I'm just going to move the ball, and it creates a sort of keyframe. It's a keyframe specific to a motion tween, and you can tell it's there because a black dot has appeared, and also this motion path has appeared. So if I go to frame 1 and press enter, you'll see it moves along that motion path. And I can also control test. Let's do a test compile, and you can see it moving there. I can use a deformity like I can with a shape, using the selection tool on the motion path. So now it will move in a curve. But I actually want it to move through the maze, which is a much more complicated motion. So I've selected the motion path. I'm just going to hit delete on my keyboard, and I'm going to lock this layer for the moment, and I'm going to create a new temporary layer. I'm not going to call it anything because I'm going to delete it in a moment, and I'm going to use the pencil tool to draw a path through the maze. So I'll just do that. I'll start here, and I'm going to turn this path that I'm drawing into the motion path for the ball. So I've got a path that I've drawn that's just in a pencil, so at the moment it's not a motion path. So I'm going to cut it, and then I'm just going to unlock the ball there. I'm going to go into the ball there, and I'm going to go edit, paste in place, and instead of pasting as a pencil, it's pasted as a motion layer. And I want the motion to be more than 50 frames. I'm going to go to the end of that motion tween. You can see an expanding icon, or rather expanding cursor has appeared. I'm just going to click and then drag that all the way to 120, where I had the background. So there's 120 frames now in this animation, and it's following the motion path that I just drew and copied, or rather cut and paste. I'm just going to delete the layer where I did that. So now if I go control test, the ball follows the path out of the maze. And as with the shape tween, I can put an ease in and an ease out, so I'll just show you an example. If I control test with ease set at 100, it's fast at the start, and then it slows down at the end. So, just to summarise what I've done, I've shown you a shape tween, which requires 2 keyframes, and a modified shape in the second keyframe will give you the different keyframe to aim for, and then between the 2 keyframes you right mouse click and create a shape tween. So that's all you need to do for creating a shape tween. For a motion tween, you have your symbol to start off with, and then instead of creating keyframes, you create just frames, ordinary frames, and then apply a motion tween to those frames using right mouse click and create motion tween. And then what I did was I went to the last frame of that motion tween and I moved the ball, and that created the motion tween effect. And then I created a motion path using a pencil tool, and then just pasting the path that I drew into where the motion path is that I'd created. So I created a motion path. It was empty at the time because I deleted the previous motion path, and then I pasted in the penciled version, and that's how I made this maze. So I want to talk about a project that I'm going to give you briefly. I'll show you how this is done later on, but I'll just show you it first. So it's a wheel that's been created, or animated rather, using a motion tween. So I want you to think about how that would be done using the information I gave in the last lesson and also in this lesson. So I'm just going to cross it off and give you some more information about that. So create a motion tween to roll a wheel 115 pixels wide across the screen with realistic movement, and the wheel should turn by 10 degrees in each frame. And you'll find a file with a wheel in associated with this lesson. And next lesson I want to talk about something called masking. I've shown you 2 different types of animation so far in Flash. One called stop motion animation, which is where you create all the frames manually, and one called tweening, where you automate the process between keyframes. In this lesson I want to show a third type of animation, which is achieved using pure ActionScript code. And I just want to show you what I'm aiming for in this lesson. The effect that we're looking at is revealing part of the stage, and the part of the stage that is being revealed is tracking the position of the mouse cursor. So this animation effect has been created with ActionScript. And I will also be showing you in this lesson how to achieve this revealing effect, which is called masking. So I've created and saved a new ActionScript project, and the first thing I'm going to do is to put the image on the stage. And to do that I'm going to go into File, Import, and Import to Stage. The image will also go into the library, but if I only wanted to go into the library I would click on the second image, but because I want to put it on the stage I'm going to import to stage, I'm going to select the image and then click on Open. The image has gone into the library and onto the stage, but it is a bit on the large side at 1800 pixels. So I'm going to reduce the size of that, and because it's a locked size, both the height and the width change together, so the height is also being reduced in size. But it's a different size to the stage at 640 by 556. The stage is 550 by 400. So I'm going to change the stage size. The way I just revealed these properties was just by clicking on the stage area. So I'm just going to change the size of the stage to match the size of the image, and then I'm going to position the image at the 0, 0 point of the stage. So I've now got the stage and the image aligned and the same size. I'm just going to call my layer background, and I'm going to create a new layer and call that mask, and that's where I'm going to put the circle where part of the stage was revealed. So to do that, I'm going to first use the oval tool. Choose any colour you want, it doesn't matter. I'm going to affect the masking. So there I've got my circle. At the moment, if I go Control Test Movie, you can't see any masking effect. To get the masking effect enabled, right mouse click on the layer and then click on Mask. You can see on the stage. And if I test compile, the masking effect has now been enabled. To return the stage to its original appearance but retain the masking effect, just unlock those layers, which locked automatically, and you can relock them again to see the masking effect. So I'm just going to unlock those because I want to link this circle rather, to ActionScript code so I can change its position using the cursor. So in order to be able to access this graphic using ActionScript, I first need to convert it to a symbol using modify convert to symbol. I'm going to have the type as movie clip. I'm just going to call it my circle. And in order to access it in ActionScript, I also need to give it an instance name, and the instance name I'm going to use is my mask. Okay, so I'm also going to create a new layer for the ActionScripts to be written in. And then to look at the actions, I go into Window Actions. Okay, so the way I'm going to do this is to add an event listener, and we've come across this before when we were listening for mouse clicks. This time I'm going to do something different, so I'm going to add event listener, event, enter frame animate. I'm just going to add a function called animate because I've said that that's what it's going to be called. So I'm not using mouse events this time, this is just a general event. And I'll just show you what it does using the trace function. It works. So if I go control test. So when I put in a mouse event a few lessons ago and I clicked, it worked, appeared once, or rather whenever I clicked it, the text appeared. This time it's appearing without me doing anything at all, and it seems to be appearing on quite a large scale. So what is this function doing? So event.enterFrame is a way of telling ActionScript to listen for an event, for the event when the animation proceeds to the next frame. So every time it goes to the next frame in the animation, this animate function is executed. and if I just cross this off, the animation is running at 24 frames per second. Now you can change that value, although if you increase it too much, slower computers might struggle with the animation because it would be a fast rate of frames. So generally it's a good idea to leave it at 24 for most projects. But you can see what's going on here is that this function is being run every time there's a new frame. So it's almost looking a bit like the timeline itself. So it's like a timeline but in ActionScript form. So I go back to the actions, window actions. The reason why it works was repeated so many times is because it was being written 24 times every second. Every time there's a new frame, it works being written to the output. So let's remove that because that's not the functionality we want. What we want is for the mask circle to track the position of the cursor. So when I move the cursor, my mask moves to the same position. So to tell ActionScript to do that, I want to access the X and Y position, the X and Y properties of my mask. Remember, my mask is what I called this mask. If I select it, the instance name is my mask. So my mask dot X, so the dot syntax allows me to access properties of my mask. X is the position along the x-axis, and I want that to be the same as stage.mouse x, which is a way of accessing the position, the x position of the cursor along the x-axis. I need to do the same with the y position. So now what the what this function is saying is sets the x and the y positions of my mask to be equal to the x and y positions of the cursor. So when I move the cursor, my mask should be set to the same position, and this is being done every single frame. So every time I move the cursor 24 times a second, the mask will also be moved to the same position, and that's what creates the animation effect. So if we just test it works, control test, and it is working, although it would be nicer if the mask was centered on the cursor rather than in that corner. So we'll just cross that off and cross this off to find out what's going on here. So click on the mask, make sure it's unlocked so you can see it and manipulate it on the screen. The X and Y position of this my mask circle is setting the position of this corner, the registration point of the symbol. So I want the circle to be centered onto that point. So I'm just going to double click onto the symbol. So it's gone in. I've now gone inside the symbol. I'm just going to move this the circle so that that registration point is at the middle of the circle, and I could do it manually like that, or I could calculate half the width and move it using the X and the Y position, or I can use the align menu, align horizontal center, align vertical center. Then to come out of the symbol I go scene 1. So now it's still setting the position of the registration point, but now the circle is being moved so the registration point is in the middle of it. So if I now go control test, I can see that the mask is now moving correctly, so it's the cursor is at the center of that mask. So let's just summarize what I've done. I've put in a background image using file import stage. Then I created a new layer and I put the circle in it, and I right mouse clicked to set it to be a mask. And then I've added some ActionScript in. I also converted that mask to a symbol so that I could manipulate it in ActionScript. I've added an event listener to listen for entering frame events, so every time the animation goes to a new frame, this animate function is executed, and what that is doing is every frame is setting the position of my mask to be the same as the position of the mouse cursor. Of course, it would be nice to put some comments in, which I will do, and I will save the file, and you can look at that later on. So in the next lesson I will be showing you how to tween the wheel that I gave you as a project in the last lesson, and I'll also be showing you as an alternative way to animate it, how to set up the same animation using this type of ActionScript code. So I want to do two things in this lesson. I want to show you how this wheel animation has been created using tweening, and tweening, as you'll recall, is the creation of frames automatically and animation between keyframes. And I also want to show you how to achieve the same effect using ActionScript. But I gave you this project to do a couple of lessons ago just with tweening, so I'll go through that first. So you should have been able to find this file called wheel.fla with a wheel in it. The wheel is 115 pixels wide. So the first thing we need to know is how far the wheel will move for a particular rotation, and the rotation I gave you was 10 degrees per frame. So let's have a look at these slides. I showed you this slide a couple of lessons ago. This is the wheel, and A is the distance the wheel will travel for a particular angle A, and we decided that the relationship was a proportionality, so this length A divided by the whole circumference is the same as the angle A divided by the 360 degree full circle. And if you rearrange the equation, and knowing that the full length of the circle is 2 pi times the radius, then you get this mathematical relationship: A equals the distance, the distance travelled equals the angle of rotation divided by 360 degrees multiplied by 2 pi times the radius of the circle. And if we put our numbers in, we have a wheel width 115 pixels, which is a radius of 57.5 pixels, and it's being rotated by 10 degrees in each frame. And we put our numbers in and we get the answer. It's moving 10 pixels per frame. So now we want to add a tween in. You could have added a single tween that had both the translation effect and the rotation effect in it. I'm going to do it a different way. I'm going to have two separate tweens, one dealing with the rotation and the other dealing with the translation. I'm going to do the rotation first. I'm going to do the rotation inside the car wheel symbol. So I'm going to double click on the car wheel. So I'm now inside the car wheel symbol, and I'm going to put the rotation tween inside it using this timeline. So I'm moving my wheel 10 degrees in each frame, and what I want to do is to move the wheel a whole turn, because Flash by default loops the animation, so it will. So if I make an animation that does a whole wheel turn, then it will continue to loop that wheel turn, and it will look like just a continuously turning wheel. So I want to turn my wheel 360 degrees, and if I'm turning 10 degrees per frame, that means I have to use 36 frames. So I'm on frame 36, and I want to insert frame because I'm about to create a motion tween. So I'll right mouse click and create motion tween. It's just telling me that this graphic inside the symbol needs to be turned itself into a symbol. So I'm just going to go OK. So now this is a nested symbol. There's a symbol inside a symbol. So I'm just going to call that inner wheel. That's the symbol that's just been created inside this symbol. I'm now going to go to frame 36, and I'm going to change the rotation to 360. So there's now a motion tween there, which is turning the wheel 360 degrees. So let's do a test compile, control test. You can see there the wheel is turning. You might be able to notice that there's a slight pause each time it rotates a full circle. And the reason for that, if I go back into my car wheel symbol, is that the position of the wheel in frame 1 at 0 degrees is the same as the position in frame 36 at 360 degrees. Those are both the same image, and so it spends, because it loops, it's spending 2 frames at one particular image, whereas it's spending just 1 frame for the rest of them. So there's a delay caused by that extra time spent on that one image. So if I'd have anticipated that in advance, I could have made the wheel turn 350 degrees and only used 35 frames. An alternative solution is to put a small action script statement in the end. So I've just inserted a keyframe, window actions. I'm just going to put go to and play 2, and all that is going to do is, when it's played through the first 36 frames, so going back to frame 1, it will always go to frame 2, so it's going to miss out frame 1 in all of the loops. So let's test that out. Control test. So I've now got a smooth animation on my wheel. So I now want to create a translation movement across the screen from one side of the stage to the other. So I'm going to move my wheel over here. I'm going to choose a convenient number to calculate with, because I'm going to have to calculate the number of frames using the principle that this is moving 10 pixels per frame, which is what we calculated at the start of this lesson. And I want it to move all the way over to the other side. I suppose that's about 900 pixels. And 900 pixels divided by 10 pixels per frame gives 90 frames. So I'm going to go to frame 90, and this is just a guess of how wide this is. Insert frame, create motion tween, and then in frame 90 I'm going to change the position to 900 pixels further across. So minus 200 plus 900 is 700. So that's moved 900 pixels in 90 frames, and that's going to be a continuous loop as well. So if I control test, now you can see it's translating and rotating at the same time. So that's how I would solve the project problem that I gave you. I want to show you how you would do the same thing in ActionScript. I've got the same wheel set up, and I've given it an instance name, myWheel, and I've also got an extra layer here with some ActionScript in, and I've set it up in the same way as I set up the previous lesson, with an event listener listening for an enter frame event, running a function called animate. So every frame this function will be executed. And I want to use this animate function to animate this wheel, which, as I said, I've called it my wheel. And the way I'm going to do that, I'll show you the rotation first of all. So my wheel, then I'm going to use the property rotation. Then I'm going to use another notation plus equals, which means add incrementally 10. So it's going to add incrementally 10 degrees each time this animate function is executed. So at every frame, the rotation property will increase by 10. So let's do a test compile, control test. And here is a interesting problem with ActionScript versus the graphical display. The graphical display will rotate around the rotation point, and I can show you that using the transform tool. See, that's rotating around the center point. If I just undo that, ActionScript will always rotate around the registration point, and the registration point is in the top left hand corner at the moment. So in order to fix that animation, I'm going to have to double click on the symbol and then center the wheel on the registration point. I'm going to do that with the align tool, the align menu, sorry. I'm just going to center it. And the rotation point hasn't moved, but now let's test it again, and now it's working. So it's just worth remembering that the user interface and ActionScript work slightly differently when working with rotations. So let's position my wheel at -200 again, and we're going to send it 900 pixels across the screen, although at the moment I'm just going to send it as many pixels as it feels like travelling, because I'm just going to put my wheel .x plus equals 10. So every frame it's going to move 10 pixels further across to the right. I'm not going to worry about it looping at the moment. I'll just show you it working. So 2 lines of ActionScript has achieved almost the same effect. I just need to get it to loop back to the start when it reaches 900 pixels further along. And I'm going to use an if statement to do that. We'll talk much more about this later on, so don't worry about it at the moment if you're not sure. But if my wheel.x is greater than or equal to 700, so if my wheel reaches point 700 along the x-axis, then put my wheel at position -200 on the x-axis. So it's going to check each time it reaches a new frame whether my wheel.x is greater than 700. So if it's at 700 pixels, when x is 700 or greater, it's going to move the wheel back to point -200. So that if statement will create the looping effect. So I'm going to go control test again, and it should now go back and play again. So you can see the advantage of ActionScript. It's a faster and more efficient way of creating that animation than using tweens. And also, when you learn more ActionScript, you'll see how versatile it is and how many different uses it has when dealing with animations. And so I'll just summarize briefly what I've done there. I showed you the tween, which I did as two separate tweens. So inside the wheel symbol I've done a rotation of 360 degrees, 10 degrees per frame, and I've combined that with a translation. I translated it 900 pixels, so the translation is 90 frames long. So I've just combined those two tweens and solved the problem I set in the project. And then I've done the same thing with ActionScript. But this time I've achieved the same effect using the rotation and the X properties of this symbol. And next lesson I'm going to talk about looping backgrounds, and we'll be finishing off by completing the car graphic, the car animation that I showed you a few lessons ago. I showed you this animation a few lessons ago. It's of a car moving past some background, and it looks like the background is kind of never ending, so it's moving forwards, this car, past an endless amount of background. And in fact that's an illusion, because this animation is reusing all these images. So as the grass goes past, you'll see the same grass going past again, and then you'll see the same grass going past again. So this is on a loop. It's a background loop, and all these images are on these types of loops. So the grass, the road, the hills, and the clouds. And so that's just a way of saving drawing a very large amount of grass, when in fact just one loop will achieve the same effect. And there's another illusion in this animation caused by the speeds of the loops. So the loop of the road and the grass is moving more quickly than the loop of the hills and the clouds, and it looks like it's closer to us, the viewer, for that reason. And in fact this is a two-dimensional flat image, so there's no distance in this image, but because of the relative speeds of these loops, it looks like towards the bottom of the stage is closer to us, and towards the top of the stage is further away. So I'm going to show you in this lesson how to achieve a background loop effect. And to start with, I'm going to show you a more simple loop, which is a series of colours going past as a kind of rainbow of circles. So I'm going to start by looking at a slide to represent that. So our frame, our stage, is represented by this square. We're going to start on frame 1 with a red circle in it, and then we're going to move this symbol towards the left so that it looks like the stage, or alternatively you could say the stage is moving towards the right. So the stage will go and finish at this purple dot, and then it will continue by looping back to the original position. So you might be able to see a potential problem with this, and I'll show you in Flash how it works. I'm going to create a tween. I'm going to insert frames first, and then create the motion tween. I'm not going to worry about how many pixels per frame it moves, I've just chosen a random kind of frame number there. And in this case, to move the purple dot to the position where the red dot is at the moment, I have to move this 1200 pixels to the left. So I'm going to put in minus 1100. So that purple dot in the last frame is where the red dot is in the first frame. So I control test. That's the last frame, and it immediately jumps to the first frame when it reaches the last frame. And you can see that it's not a continuous loop, because the purple is instantly replaced by the red, and that spoils the the continuity of this particular loop. So we're going to have to rethink that idea. You can see here that those are the two the frames, the last frame of the animation and the first frame of the animation. You can see there's an instantaneous change, and that's what breaks this particular loop. So it'd be much better if instead of a purple dot at the end, if it was a red dot at the end. So in order to set that up, it would look something like this, with a red dot at the end and a red dot at the start, and that might create our loop. So let's see how that works. I'll just remove this tween, and let's go into the symbol, double click on it, and Control C to copy that red and paste it at the end. So it now looks like what it looks like in the slide. Red dot at the beginning, red dot at the end. Let's put our motion tween back in again. This time I'm going to have to move it 1400 pixels to get the red dot at the end to the position of the red dot at the beginning. So I'm going to take that to minus 1300. And let's do a control test. So red dot at the end, red dot at the beginning. And you can see there's still a problem there. Let's have a look at it in the slides to see it better. So there's our last frame, and there's our first frame, and you can see that they're not the same image. So there's a bit of white space there, a bit of white space there, and those look different in those two frames, and that's what is currently breaking our loop. So the thing we need to do is to have these two frames must look the same in order to make our loop continuous. So we're going to have purple in the first frame and orange in the last frame. And so we're going to have to set up our dots like this, so that there's purple at the start and orange at the end. So let's do that in Flash. Let's get the purple dot, Control C, Control V to copy and paste it. Then the same with the orange. Let's put the tween back in. I'm still wanting to move the red dot at the end to the position of the red dot at the beginning. And to do that, I'm going to move it 1400 pixels in this case. It's just because of the length of this particular symbol. And I'm going to Control test it. And now you can see it's looking like a continuous loop. But there's still one minor issue, and that is that the end frame is the same as the start frame, and in this loop it's going to spend 2 frames on the same image, which will create a slight delay, and you might notice it in the animation if you look carefully. So I'm just going to do what I did in the last lesson. I put in a new layer. I'm inserting a keyframe in the last frame, and I'm going to put some action scripts in there. Go to and play 2. So that's going to miss out the first frame in each loop of this animation. And what that means is it's only going to spend one frame on the last, on the initial image, and also which is the same as the last image. So I've now got myself a continuous loop, and that's the basic principle of creating all background loops, that you must have your first and your last image the same, You can see it better on the slide. So the last image there is identical to the first image, so that when you switch this symbol back to the original position, you don't notice it. So the project that I'm going to give you now is to do the same with the car that I showed you at the start. And it's quite a complicated image, but each of the layers has to move 640 pixels, so it's not too bad to add some tweens to those. Although if you're feeling adventurous, you can also do the same in ActionScript. The thing to remember though with these tweens is that the further back in the image you go, they're going to have to move more slowly, so you're going to have to set it up to do that. I'll show you an example with the road. I'll just show you how it's set up. So you can see that there's, like in the rainbow, there's a repeat of what is shown on the first stage. So this is the first image in the first frame, and the image in the last frame is off the stage at the moment, but it's exactly the same, so that when the loop reaches the end frame and when it jumps back to the first frame, you won't notice the difference because the first frame and the last frame are exactly the same. Okay? So I'm going to show you the road as an example. So it might help if I just make the car invisible, so it's more clear that the first and the last frames are the same. Double click on the road, and actually I'll just show you something else first. Control test. You can see I've already set the wheels to move, and those are moving at 10 pixels forward per frame, so the road's going to have to move 10 pixels backwards to make it look realistic. So let's get rid of our car again, double click on the road. Now I said it has to move 640 pixels to complete the loop. So because it's moving 10 pixels per frame, that means I'm going to have to go to frame 64 to make 10 pixels per frame to move 640 pixels. So I'm going to insert frames in frame 64. Then I'm going to create my motion tween. I'm going to move this backwards by 640 pixels in the last frame. Okay, so that's what the last frame looks like. I'm also going to add in my keyframe and my actions. Go to and play 2, just to make sure it doesn't stick on the same image for 2 frames. And let's test that out. So now we've got the road moving. Okay, so if you can do the same thing for the other layers, remembering that the other layers are going to have to be slower, which means they're going to have to use more frames, which will be a lower number of pixels moved per frame. And as I mentioned, if you want to do the same thing in ActionScript, then you're welcome to have a go, and I'll leave the project files in a place that you can find them to check your work with. So I'm going to be leaving animations for a few lessons and focusing instead on ActionScript coding again. And then we'll return to animations later on when we can apply more complicated ActionScript to them.